Welcome back to the system design series. I want to get into a very specific part of RabbitMQ that can have serious implications on your system design and also can have implications as to how you structure your message that you send in your system. This is going to be context specific. It's not going to be applicable in all situations, but I'm going to explain a context where it really does matter that you make sure you have this set. So RabbitMQ implements or adheres to the AMQ protocol. It's an implementation of that protocol, and part of that is when you publish a message, that message has three core frames. It basically has a publish frame, a header frame, and a body frame. That header frame has basically a subset of properties associated with that header frame. And some of the properties I have listed here. So you have delivery mode, and then you have expiration, reply to, another headers, priority, timestamp, type, content type encoding. There's a lot of them, but the ones we're going to be focusing on today are the delivery mode. So delivery mode you can have set to be 1 or 2. Delivery mode 1 is non-persistent. Delivery mode 2 is persistent. And what this basically means is delivery mode 1, a non-persistent message, is in memory storage. Wow, that box, you see that? All right. Non-persistent is in memory storage, where persistent is disk. So this means that if we publish a message with the delivery mode set to 1, that message is only going to be stored on the actual server's memory, the memory that's been allocated to that server. So if the server, for whatever reason, has some kind of interruption or it goes down, that message is going to be lost, and we're going to have no way of tracing what message was lost. There's no way to know what happened. If we set the message with a delivery mode of 2 being persistent, that message is saved to the disk. So the disk will be your server's hard drive. It might be the attached volume. It might be it's some attached disk somewhere that is going to save that. Your computer has your hard drive. It would be the same thing. So if our RabbitMQ server went down, that message would be saved on the disk, and we would be able to persist that message, through some kind of interruption or server outage or whatever it is. So that's going to be a more permanent way to persist your messages in the event that something happens to, the RabbitMQ server. This is very important to consider because it has implications as to, how our application is sending a message to RabbitMQ and how we're treating, what's the fault tolerance like? What's the resiliency plan here? So, basically in the context of this, so if we have an application, let's make that. Hold on. Let's make it a circle. So if we have our engine, API, our engine API is going to be sending data or publishing data to RabbitMQ. And we've decided that, we don't really care, about any properties on the message frame. We don't care about that. All we just wired it up really fast and we're just publishing data to RabbitMQ. What we didn't know is that under the hood, that delivery mode is being set to 1. We just didn't know that. So let's say we've sent that message, and then it's all good. We have properties. I'll just make it easy on ourselves. We'll just do delivery. So we're setting it to be 1, right? We weren't paying attention, and whatever whatever library that we're using to connect to RabbitMQ doesn't automatically make the persistence mode 2. It just leaves it as 1. If that's the case and our RabbitMQ server goes down, well, that poses a problem later on downstream in this whole process, because if we have a consuming application, which in this case was our Rust microservice, that Rust microservice is not going to receive that message when this RabbitMQ server reboots, restarts, whatever it does. That message is going to be lost in this case. And that poses a problem, because if we have another, I'm gonna give this like Q here. That poses a problem because the general flow, if you remember back from the beginning of our project, is our Rust microservice is publishing messages back to another queue that is ultimately being consumed by our engine API. And that Rust microservice is sending notifications about, what the state of the engine is. And so if this queue goes down, or it's, our whole RabbitMQ server goes down, and we don't have the persistence mode set to 1, or the delivery mode set to 1, the message is lost here. Right at this stage, the message is lost. So that Rust microservice, when the RabbitMQ server restarts, is never going to receive that message. Therefore, it's never going to send the notification back to the other queue, or publish the other message back to the other queue, saying that, maybe the engine's overheating or whatever. So data is going to be lost, and the API then does not know the state of the messages. The API, all it knows is that it's publishing a message somewhere and it's consuming a message somewhere. It doesn't know the state of the rest of the system. But that's a problem, because then we are missing information from what's happening with our engine. But if we had paid a little bit of attention, and we had made sure that we're covering all our kind of basis in our design here, if we know for a fact that the delivery mode is in fact set to 2, then we can be a little more assured that our data, in the event that this server goes down, will still be consumed once it goes up by the Rust microservice, because the delivery mode has been set to 2, which is persistent, and it's written on the disk as opposed to in memory. So that can give us a little more confidence. But that's only half the battle, because the other problem is that we can set the delivery mode to be persistent on the message frame on, per message being sent to RabbitMQ, but we then have to go another step and say, okay, well, we need to make sure that our queues are marked as durable. And if they're not marked as durable, that's going to be a problem for us, because if the durability of the queue is not set, that means when the server dies, that queue is going to be automatically deleted. It's gone. And if that's a problem, because, well, if our messages are written to the disk of that queue, there's no guarantee those messages will persist in the event that queue is deleted. So that would be something to test for sure. But it's another point of configuration that you just want to make sure you have correct, is that your queue durability is set to durable, and your delivery mode is set to 2 if you need to be very, very sure that you're never missing any data. So if you're dealing with any sensitive information that can't be lost, you got to make sure that you get the persistence right. In our case, our engine project, we don't want to miss any log statements that indicate our engine is overheating, because that could cause damage to the engine. So that's why we need durability for the queue, and also our delivery mode set to 2 in our system. So as long as those things are set, you should have a pretty robust and system that inspires some degree of confidence in the people using it. Now that's not 100% foolproof, right? You still need some fallbacks as to, you know, maybe the message just didn't get delivered successfully for whatever reason. You need some form of error queue, and how do you handle that? You obviously need some additional checks to this, but I want to show you inside of RabbitMQ what really this actually looks like. And it's not super crazy. So I have a queue actually. Well, let's go to my queues. I have an engine queue that has 60,000 ready messages. I think this was from one of our load testings, but I'm actually going to fetch one of the messages and I'm going to show you the properties on there. So I'm going to get message and I want to show you what it looks like. So this is a typical structure of a message inside of RabbitMQ. So you can see the exchange. I don't have any routing key because it's a fan out exchange. Then you're going to see properties, and the properties has the delivery mode. So because it's 2, that means I could tear down this container, this running RabbitMQ server, the container, and then start it back up like I've done every time, and the messages are still here. But if they were set to 1, those would be lost. So in a real world setting, that's probably not the ideal situation to have. And if we also look at the queue details here, you can see that there is a features and durable set to true. And because that's true, this queue is not going to be deleted. But I do want to test something that I said earlier. I actually do want to see what happens if we leave the queue durability set to false, but we leave message persistence on. I just want to see what happens. So we have actually a queue we should be able to use here. So I had to start that, and I forgot that I was using it in another video, so I had to uncomment some code again. But we're back in Postman. So if I send this message in Postman to that endpoint, then we can go to RabbitMQ, refresh, and we'll see the message pop through and go to 5. So if we go ahead and get one of these messages, we can see that the delivery mode is 2. I believe that's the default for mass transit, which is nice. So we are going to basically stop this container. I'm going to stop the RabbitMQ and I'm going to start it again. Obviously, there's not going to be any impact here. And let's go back to the logging queue. So you can see everything is still there, right? Everything is durable. But I do want to change this, and I don't know if you can change durability. You may have to make a new queue, which is fine. Let's go ahead and make a new queue, and I'm going to set the durability to transient, and I'm going to call this logging transient, and everything else is the same. Type default for virtual host, and I'm going to go ahead and add queue. So I now added a new queue. What I'm going to do is just bind that queue to my logging exchange. I'm going to add logging, what do I want to say, transient? Yeah. Okay, I want to bind that. So now we have a logging transient queue, and that's bound to my fan out exchange. So I'm going to go ahead and send another message in Postman, and we should see it come through. There it is. I'll send a couple more just for the sake of the video. Okay, let's go back to RabbitMQ, and we have 3 messages. I'm going to go ahead and get one of the messages. You can see that the delivery mode is 2. However, on the queue itself, there's no, the durability is transient. So I'm trying to see, the feature looks weird in this one. Okay, but this one is marked as transient. So what I'm going to do is now tear down this running container again. I'm going to stop it. So we stopped it. And I'm going to restart it. Okay, it's started. And you see this error message. The object you clicked on was not found. There it is. I don't have a logging transient queue anymore. And those messages are now gone. So you can see, but let's go ahead and just make the queue again. Let's make it transient, just to show you that the messages are in fact lost. Let's go ahead and name it the same thing: logging transient, add queue, and we want to then bind that to the same exchange that we did. Do I get the logging transient? Okay, we bind that, go back to the queue, and there's no messages. Let's go ahead and send a message to that just to be certain. We're wired up all right. Okay. So that's just one thing that I want to call out specifically, is that you can set the message delivery mode to persistent, but if your queue itself isn't set to durable, then you have a problem on your hands, because then you've basically created yourself a false positive in your system, which is bad. So it's just all these like small configuration things that you want to have documented for a fact. And you want to make sure that everybody's clear that your messages are not going to be lost in the event of an outage. Server outages are inevitable. It's just a matter of when it happens. And you want to be prepared for that and have all these, have all your configuration things very well documented and very well understood, because these are the things that just cause the headaches, right? The things that you think are set but are not, and then you realize that they're not because you thought they were the default setting, which a lot of the times they are. So a lot of libraries set the persistence to 2 by default, and RabbitMQ builds a queue as durable by default. But you just never know. These are the things that, what if somebody made a queue as transient because there was a use case whenever that, you just never know. So you just want to make sure, and that you don't want to take for granted a external library doing this for you. You just want to make sure and be aware of the configuration properties that are available to you to set. So that's really what I want to call out here. I did an experiment, showed you, and hopefully that made sense. There's a lot of really, really interesting stuff in RabbitMQ. Honestly, it's a insanely powerful technology. Again, I'm going through RabbitMQ in Action, which is another book. I've gone through RabbitMQ in depth, and we're just scratching the surface in terms of what we can do once we start getting into clustered. RabbitMQ nodes running. There's just so much we can get into. I've tossed around the possibility of making my own RabbitMQ extension. You have to write it in, I forget what language it might be Erlang, I think, which I don't know. But I really want to make this specific extension. I'm not gonna say what it is now, but I don't know. I'm kind of going back and forth on that. But there's a lot of message properties, and there's just a lot of stuff that you can do in RabbitMQ that we can make content on. So Uh, yeah, thank you all for watching, and I'll see you in the next one.